Hey there guys, this is Math 148, section 12.3, and this is the second video in this section. In the first video I looked at the integrals of exponential functions, and in this video I'm going to show you how to do integrals with involving logarithms. Your book is careful to say we're not actually taking the integral of like natural log of something, so we're not doing that, but here is rule number one. We're looking at integrals that involve logarithmic functions. So it's kind of the opposite of our derivatives of log functions. Here's rule number one. Suppose you have a function that looks like this, or an integral. We want to take the integral of 1 over x dx. So the rule is this is equal to the natural log of the absolute value of x plus a constant. You have to take the absolute value of x because you can't take the natural log of a negative number. So the absolute value of x just ensures that you're going to be able to take the natural log. Here's an example of this. Suppose I said, find the integral of 4 over x dx. Well, if you're sitting there alone with your paper, you'll say, I recognize this x on the bottom. So I'm going to take the 4 out in front because it is a constant. And that leaves me with 1 over x dx. And now I can use this nice formula and say that is equal to 4 times natural log of absolute value of x plus a constant. And you just leave it like that. Don't bother trying to simplify the absolute value. Just leave it. Okay, so that's rule number one. And again, if you're if you want to check this, suppose you said, well, I got my answer of 4 natural log absolute value of x plus a constant, and you want to check it. That's equal to some function y, say. I'm going to take the derivative to check. You can always check with integrals. Check to make sure that the derivative equals the integral. So the derivative of this function is 4 times, you're thinking, oh no, I don't know how to take the natural log of absolute value of x. That's one reason I bring it up. It's the same essentially. The derivative of the natural log of the absolute value of x is hard to say, but it's still just 1 over x. And there's a nice explanation in your book on page 768 that just shows you that this is true. But if you want to check your answers, just know that when you take the natural log of the absolute value, it's still 1 over x. And then there you are. So a derivative of a constant is 0. So you look at this 4 over x, and we're checking to make sure our integral is right, and that was 4 over x. So again, you can still check your answers with these problems. Here is rule number 2. Yay for rule number 1. Okay, I'm going to write it like this. It's just kind of the second part of this. If we have the integral of 1 over u, some function u, 1 over some function times the integral of that, the derivative of that function, du. So we have some messy function, and we have the derivative of that messy function. The answer is natural log of the absolute value of messy function plus a constant. So this is the rule. So if you want, you can write this on your note card, but only write it on your note card if you're going to be able to look at it later and know what that means. So here's an example of how to use this. Question number 17. Suppose you have this integral that is 3x squared divided by x cubed plus 4 dx. And some of you are thinking, hey, you said this was about log functions. There's no log in this. I'm just stuck with a messy integral. Calm down. You are correct. There are no logs here, but there will be a log in our answer. So for these problems, what I want you to do, first of all, you notice that it's messy, and you notice that it has a fraction. Do you see you have messy thing divided by messy thing? All right, we'll focus on the bottom here. This bottom thing looks like this, the 1 over u. That's going to be your u substitution. So try this. Give it a shot. This is your method for trying to get yourself out of this situation. U equals x cubed plus 4. For your u substitution, let it equal the messy function in the denominator. Now we take the derivative. Du equals, bring the 3 hops down in front, 3, take away 1 is 2, derivative of 4 is a constant which goes to 0, so that's 0. and then we have dx. Ha-ha! I am victorious. That was my ha-ha victorious noise. So what we have shown here is now we have 1 over u on the bottom, because that took care of this part, right? Because the 1 over x cubed plus 4, that's 1 over u. And on top, we have 3x squared dx. So now we have the derivative like that, du. So once you have it so that you have the derivative on top you want the derivative of the function, and on the bottom you want the function, right? Whatever the messy function is. So you want derivative divided by function, then you can just use this natural log answer. So you think, I know the answer is natural log absolute value of u plus a constant. But you're not done yet, because you remember, because I told you that you have to substitute u back in. So your final answer is natural log absolute value x cubed plus 4 plus a constant. Okay. I'm going to show you with this one how to check your answer. Again, I'll use blue, checking with blue. You have extra time on your test and you just said, well, I got the answer as natural log of x cubed plus 4 plus a constant. I'm going to do a derivative check. The derivative of this is 1 over x cubed plus 4, because you're sort of essentially ignoring the absolute value, times, take the derivative of what's inside, 3x squared, derivative of 4, oops, sorry, there's no constant. Oh yeah, there was a constant. Derivative of a constant is 0. So your final answer here is 3x squared over x cubed plus 4. Then you go back to the problem and you look what was in the integral. Yep, that's it. 3x squared divided by x cubed plus 4. 3x squared divided by x cubed plus 4. So you can check all your answers. So you can always get 100% on all the integral ones. Okay, let's do another one. I got white this time just to shake things up. See if you like that better. Question number 25. Find the integral of 3x squared minus 2 divided by x cubed minus 2x dx. And again, when you look at these problems, you first notice that you have a fraction, right? Fraction. And both of these fractions are messy things. Two messy functions in a fraction tells you that you are in this section and you want to focus on the denominator. So we're going to let u, our u substitution, be the denominator. I'm going to see if we can get it to work. Again, just like the other section, take the derivative. 3x squared, 3 goes in front, subtract 1, it makes that 3x squared, minus 2 dx. Aha! Right? Check it out. So now this is exactly perfectly the integral of, this is u on the bottom, that's the function, and on the top we have the derivative, du. So on the bottom we have the function, and on the top we have the derivative of the function, and we are good to go. So we write, haha, home free. You can make that noise during a test if you want. It won't disturb anyone, I promise. Natural log of u plus a constant. You're not done yet. You substitute back. So your final answer, it's hard to read the yellow on the white. Natural log, you substitute this back in for u of absolute value, x cubed minus 2x plus a constant. This paper is so colorful looking. Looks like a little child's integration problem. One more. Question number 21. Here it is. Your last problem. What I'm going to do with you, you can do more on your own. I'll let you. Integral of 6x cubed divided by 2 times x to the 4th plus 1. That's 2 times x to the 4th plus 1 dx. Again, you're going along in the math problem and you see this fraction and both of them are messy. So where do you focus? What do you let u equal? Sorry, I forgot about the yellow not working. Let u equal, yes, this bottom piece, this messy thing on the bottom, that becomes your u substitution. 2x to the 4th plus 1. Now we take the derivative. Du equals 8x cubed And then 1 goes to 0 because the derivative of 1 is 0. Haha, we think, well, it's not exactly what we would want, right? On the bottom, we have this. I'm just going to rewrite this because it's not exactly in the form I want it to be. See how there's a 6 up here and an 8 here? I really want that to be an 8, and then this whole top piece would be the derivative. So what I want is 8x cubed dx. That's what I want it to look like, but I can't just put an 8 there and change the 6 to the 8 magically. Except I kind of can, because look what I did. I just put the 8 there, but that means I have to bring a 1/8 out in front, and I'm bringing the 6 out in front because it's a constant, so I can move it wherever I want. It goes to the bench. 6 is benched. And then 8, I want 8 on the inside, so I have to divide everything by 8 too. So I have multiplying by 8, dividing by 8. It all works out. So this is now 6/8 times, I can recognize this. Here, this bottom one now, we're back to, that's u. This top one is the derivative of u. So we have derivative u du, and it looks perfect for our lovely formula, natural log absolute value of u plus a constant. And the final step is always to put that, I'll just leave it red, 6/8, put the u substitution back, absolute value of 2x to the 4th plus 1, end of absolute value, plus a constant. And that is your answer. So that's how you do these. Make sure you can do a few of these for your test also.